In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery, leaving astronomers the world over awestruck. A few weeks ago, the telescope discovered the earliest known galaxy in the universe. But now, it has discovered something even larger, a supermassive black hole moving away from its galaxy at an incredible speed of 4 million mph. This most recent finding has very important implications and has generated much speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Space Telescope was sent on a mission to investigate the first galaxies in the universe and has captured stunning images of the death of stars and galaxies from a few 100 million years after the Big Bang. We invite you to join us to explore the latest discoveries from this telescope. Keep up the good work by liking and subscribing to content like this one. The latest discovery is challenging the scientific community's current understanding of black holes. In most cases, black holes are thought of as huge entities that pull everything, even light, toward them. But the recently observed black hole appears to be working against this. It is not able to absorb light, creating new young stars along a long trail. This new trail of newborn stars has been observed following the black hole that spans a staggering 200,000 light-years away. Scientists are puzzled by the unusual behavior of this black hole compared to others, but a team led by Yale Astronomy, Professor Peter B. recently reported their findings in the astrophysical journal Letters. NASA's Hubble Space Telescope also confirmed these observations, indicating that when it moves, a black hole makes new stars, comes into contact with gas, and cools it. We are seeing the wake behind the black hole. However, NASA has also developed an exciting announcement about the galactic fusion ARP-220, which was captured by the James Webb Space Telescope. This impressive galactic merger stands out from the crowd of galaxies in the night sky. The phenomenon occurs when two spiral galaxies merge, known as ARP-220, which shines brightest in the infrared, making it perfect for observation by the James Webb Space Telescope. It is classified as an ultra-luminous infrared galaxy with a luminosity of 1 trillion suns. Compared to our own galaxy, the Milky Way, which has a much lower luminosity of about 10 billion suns, ARP-220 can be found in the Serpent constellation, approximately 250 million light-years away. It is considered the brightest of the 3 closest galactic collisions to Earth and is listed as object number 220 in the Atlas of Peculiar Galaxies. About 700 million years ago, 2 spiral galaxies existed, resulting in a massive star explosion formation. This created a dense region approximately 5,000 light-years across, containing about 200 large star clusters. Surprisingly, this small area contains as much gas as the entire Milky Way. Previous observations with radio telescopes discovered about 100 supernova remnants in less than 500 light-years across. Then the Hubble Space Telescope revealed that the parent galaxies are located 1,200 light-years apart, and that each core contains a rotating ring of star formation that produces brilliant infrared light. The most recent views from the James Webb Space Telescope demonstrate an impressive merger of the 2 galaxies. This image also shows faint tidal tails extending from the outskirts of the merger, indicating the gravitational pull between the 2 galaxies. Finally, the red, cyan, and orange concepts of streams and filaments scattered organic materials in ARP-220. Another stunning discovery stumped scientists when researchers found primordial galaxies at the edge of the universe. They didn't believe in their authenticity. Some people believed they could be disguised nearby galaxies, so they shared the information with other researchers around the world, hoping for the best. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the oldest galaxies ever seen. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, providing us with insight into the distant past of the universe. These galaxies were discovered when the universe was young, which sheds light on how quickly the first generations of galaxies emerged. The spectral data established that these galaxies are situated at the edge of our view, some even farther away than Hubble was able to see. The finding is important because it confirms one of the most crucial responsibilities of the James Webb Space Telescope: to study the early universe by means of light that has traveled over 13.5 billion years. The ability to measure extreme redshifts is what sets James Webb apart, allowing astronomers to peer into the infrared range and observe the first galaxies in the universe. The excitement in the air is palpable, as this discovery marks an important milestone in the discovery of the universe and in understanding its evolution. The discovery has had a major impact on our comprehension of the universe and prompted NASA to develop even stronger telescopes than the James Webb Space Telescope to determine whether our understanding of the Big Bang is correct. The data from the Webb spectrometer and near-infrared camera discovered that 4 of the 6 primordial galaxies have extreme redshifts, suggesting that Webb is looking at them as if they were real, 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising since the universe is estimated to be 13.8 billion years old, and the fact that these galaxies exist suggests that we need to revise our understanding of the early universe. This has raised questions in the scientific community, as these new discoveries challenge the current cosmological Big Bang theory and the inflationary model, which has some loopholes, such as going against the law of thermodynamics and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope has found galaxies almost as old as the Big Bang itself, which raises questions about what we thought we knew about the origin of the universe. According to theoretical physicist Miyawaku, the discovery of old galaxies found by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. In the past, these galaxies were thought to be less developed than the Milky Way, but the new findings suggest that we may be missing crucial information. The fact that the telescope has identified 6 galaxies that came into existence 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises the question of whether our current theories about the creation of the universe are correct. As explained by Kaku, it necessitates that it took a galaxy billions of years to develop, like the Milky Way, so it is strange to find such large, young, primordial galaxies. This finding may necessitate our editing and redoing the textbooks on the beginning of the universe. Findings from the James Webb Space Telescope challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another intriguing piece to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow in size and become something similar to the colossal Coma A656 cluster. This event is one of a kind and unique in that it is located in the accelerating galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of these 7 galaxies, which gives them the confidence to confirm that they are connected by a protocluster. To put this in perspective, NASA researchers made a comparison between these galaxies to small drops of water in different rivers that will eventually come together to form a massive and powerful river. Clearly, what we previously believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows? Maybe the Big Bang did occur, but the cause is a different story. In any case, we will have to anticipate additional discoveries, but the answer may be closer than we think. What do you think about these discoveries? Share your thoughts in the comments box, and I hope to see you in the next video. Thank you so much for watching.